Hello students. Today we're going to do Uniform Motion Part 3, Unequal Distances, which is Saxon Algebra 1, Lesson 99. We have learned how to solve the following two kinds of uniform motion problems, where the distances are equal, going the same distance, or coming and going. I obscured a little bit. Where the distances add together, having a meeting point, or having a parting point. In this lesson, we are going to learn a third type, where the distances are not equal. Somebody is ahead. In this case, Patroclus goes ahead of Achilles, or somebody is already behind. Charlene starts out behind Rachel. Example 1. At 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? What an interesting problem. First, let's jot down the information the problem gives us. Achilles' rate, which we'll call R sub A, equals 20 kph. Achilles left at 8 p.m., and Patroclus left at 10 p.m. The problem ends at 3 a.m. At 3 a.m., Patroclus was 50 kilometers ahead of Achilles. Next, what is the problem asking for? Patroclus's speed, which is the same thing as rate, and we'll call it R sub P. What kind of diagram could we draw for this problem? Both Achilles and Patroclus started from the same point. Later, Patroclus was ahead of Achilles 50 kilometers ahead. This diagram sums up that information. Once we have our diagram, we are practically home free. We can clearly see that d sub A plus 50 equals d sub P. Distance equals rate times time. So d sub A equals R sub A T sub A, and d sub P equals R sub P T sub P. We already know that R sub A equals 20, and we are looking for R sub P. So, putting in that information, we have 20 times T sub A plus 50 equals R sub P T sub P. We can get T sub A and T sub P from the problem. Achilles started at 8 p.m. and ran until 3 a.m. That is 7 hours, so T sub A equals 7. Patroclus started at 10 p.m. and ran until 3 a.m. That is 5 hours, so T sub P equals 5 hours. We're ready to go. Our equation so far, 20 T sub A plus 50 equals R sub P T sub P. And we're going to substitute the hours that we figured out in the last slide. So we have 20 times 7 plus 50 equals R sub P times 5. All that's left now is doing the math. 140 plus 50 equals 5 R sub P. 190 equals 5 R sub P. R sub P equals 190 kilometers divided by 5 hours equals 38 kph. Patroclus ran at 38 kph. For 5 hours, maybe he was in a chariot. Example 2. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kph and Charlene travels at 100 kph? First, let's jot down the information the problem gives us. Rachel has a 15-kilometer head start. Rachel's rate, which we will call R sub R, equals 70 kph. Charlene's rate, which we will call R sub C, equals 100 kph. Next, what is the problem asking for? How long will it take Charlene to catch Rachel? The problem starts when Rachel takes off the problem starts when Charlene takes off after Rachel. Rachel is already traveling. The problem ends when Charlene catches Rachel. Therefore, the two girls are traveling for the same amount of time. T sub r equals T sub c. What kind of diagram could we draw for this problem? Rachel started out 15 kilometers ahead. Charlene started from the same place but caught up with her. This diagram sums up that information. Once again, our diagram is a huge help. We can clearly see that d sub c equals 15 plus d sub r. Or r sub c t sub c equals 15 plus r sub r t sub r. The two girls are traveling for the same time, so t sub r equals t sub c equals t sub r, and I will substitute t sub c for t sub r. Doing all the substitutions, 100 times t sub c equals 15 plus 70 times t sub c. Doing the math, 30 t sub c equals 15. T sub c equals 1/2, which means it will only take Charlene 1/2 hour to catch up with Rachel. Example 3. Harry and Janet jog around a circular track that is 210 meters long. Janet's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute. In how many minutes will Janet be a full lap ahead? First, let's jot down the information the problem gives us. The track is 210 meters long. Janet's rate, which we'll call r sub j, is 230 meters per minute. Harry's rate, which we'll call r sub h, equals 200 meters per minute. Next, what is the problem asking for? How many minutes before Janet is one full lap ahead? One full lap means once around the track, which is 210 meters. This is an example of a problem where one person gets ahead. The diagram will look like the one for Achilles and Patroclus. We don't really care how many laps they did before Janet was one full lap ahead. It also isn't important that the track is circular. We can use straight lines. This diagram shows that they were both jogging, and now Janet is 210 meters ahead, one full lap. We can now clearly see our distance equation. D sub j equals d sub h plus 210. R sub j t sub j equals r sub h t sub h plus 210. We need times. Now think. These two will have been running for the same amount of time when Janet gets ahead, so t sub j equals t sub h, and I will substitute t sub j for t sub h. Substituting. 230 times t sub j equals 200 t sub j plus 210. Doing the math. 30 t sub j equals 210. T sub j equals 7. Janet will be one lap ahead after 7 minutes. I hope that you have seen how helpful the diagram can be. I also hope that you realize you need to think a bit when you do these kinds of problems. And finally, I hope that this has helped you to master this lesson. See you later.